The next part that we are going to talk about in terms of computations that are made for the purpose of economic analysis is the deciles. Now, deciles is a very important terminology which is used for the purpose of measuring wealth and income distribution. So, if we talk about what is the income groups in a particular region, so take an example like what is super rich, elite class, for example. Then there could be the upper middle class, there could be the middle class, there could be the lower middle class, then there is lower class, poor or below poverty line or whatever. So if these type of classes are to be decided or designed in a particular economic situation, in a village, in a city, whatever the case is, so for this purpose, deciles are something which can be used for arranging the statistical data that is available and giving you a clear idea of, you can say, the divisions and the distributions that are there in that particular class. So this division, let's say, of income can be used for the purpose of deciding on whether a particular class deserves a subsidy or not. So elite class, upper class may not be given the subsidies, but lower class are given the subsidies. So it's, for example, in case of ration cards, which we have, where free food and food grains and such other things are given to the people. So there is a class of people who get the ration card which has a specified color code, and based on that you get the free food or the food at a very low price if you fall in that particular class. If not, then you will not be eligible. So deciles are a very important economic analysis tool which, when used, can give you a better understanding of the economic situations. Now, what is done in deciles computations? Deciles basically, decile is something which talks about 10. So division of the data into 10 parts, 10 sections. And if you have to divide a particular line or a particular data into 10 sections, how many points would you need? You would need 9 points, right? So deciles are 9 deciles for the purpose of that statistical calculation. And even here, the data is arranged in ascending order. Now see the formula for computation of deciles. Deciles calculated from D1 to D9 for individual and discrete data, and they use this particular formula. For J is basically when we are talking about the one of decile 1, decile 2, whatever, is equal to J into brackets n plus 1. N is what? The number of observations again, right? And divide by 10, because we are grouping the data into 10 parts. This is for individual and discrete data. What about group data or continuous data, as we have the second part? Here we will use dj is equal to L. L is what? Lower limit of the decile class. So first we find out the decile class by the first formula, and then we use the second formula where lower limit is taken, then frequency of Jn divided by 10 minus Cf upon F into this entire whole thing will be into H. So what is L? L is lower limit of the decile class, then plus Jn. Jn will be what? The J is for the decile number 1, 2, 3, 4, whatever, into N is the number of observations, and minus Cf is the cumulative frequency of the class. Which class? Preceding class of the decile class, right? The class preceding the decile class. And H is upper limit of the decile class minus lower limit of the decile class. Okay, just like similar to quartiles what we had computed. Now take into consideration the example which shows how individual data is calculated. So calculate D4 and D8 for the following data. So decile 4 and decile 8. So first thing, what do? You arrange that data into the ascending order, 7, 8, 9, 10 till 15. Then D4 is equal to what? The formula says is J into brackets n plus 1 upon 10, right? So your J is what? We calculate 4, decile 4. So 4 into bracket n is how many number of observations you can see here? There are 9 observations. So 9 plus 1 upon 10. So if we compute, this will be 4. So size of the fourth observation is 10. So D4, decile 4 is 10. Got it? D8 now. Decile 8, we use the same formulation. What is it? J into brackets n plus 1 upon 10. The whole thing, that becomes that number of observation. So D8 is equal to size of 8 into brackets n plus 1 upon 10th observation, which is size of 8 into brackets n is 9 plus 1 upon 10. So size of the 8th observation. What is the 8th observation in this? It is 14. So decile 8 is 14. Got it? So it's very simple for the purpose of individual data. Now another example, if you see, D8 you need to calculate from the following data. Again, arrange it into the ascending order. Take the size of 8 into brackets n plus 1. How many number of observations in this case? There are 10. So we take 8 into brackets 10 plus 1 upon 10. So it is size is 8.8. 8th observation plus 0.8 of what? The thing between 9th and 8th observation. So 9th observation is what? 19 minus the 8th observation, which is 18. And so finally we get D8 as 18.8, right? So decile 8 will be in this case 18.8. Now for discrete data, marks are given and number of students are given. In this case, as we calculated for quartile, same way we calculate the cumulative frequency in this case. So take the total number of students. How many students are there? N is 39. Okay. Marks are given from 10 to 60 and number of students are 39. So cumulative frequency we calculate 5. 5 plus 6 is 11, 11 plus 4 is 15, and so on. And now we use the two formulas. Decile 2, we are calculating size of 2 into brackets n plus 1 upon 10th observation. So size of the 8th observation is what we get, and 8th observation lies in cumulative frequency 11. So check 8th observations 5, number of students 5, and we need 3 more, right? What is this? It will go in the next class, that is the marks of 20, and cumulative frequency for that is 11. Got it? Hence D2 is 20 marks. Now coming to D4, same way we compute 4 into brackets n plus 1 upon 10. D4 size of 4 into brackets 39, that is number of observations is 39 plus 1. So size of the 16th observation. Now 16th observation lies in cumulative frequency what? 20. Correct? Between 15. 15 ke baad what is it? It's just 20. So it lies in 20 cumulative frequency. So if you look at the marks are what? 40. So decile 4 is 40 marks. Fine. Now talking about continuous data. So we need to find decile 5 and decile 7. Now here we need two formulas as we had seen earlier. Now same way what we do, arrange the marks, the number of students, and we take the total number of students. So they come to 100. Cumulative frequency we compute 10 plus 10 plus it becomes 20, 20 plus 40, 60, 60 plus 20, 80, 80 plus 20, 100. Now once we find cumulative frequency, what is step 1? We find decile 5, right? Use the same thing, decile 5 with the formulation 5n upon 10, 5 into 100. Number of observations is 100 divided by 10. So it is 50th observation. 50th observation lies in cumulative frequency 60. So the decile class is what now? 20 to 30. Got it? Now step 2. For this decile class, we need to actually calculate the D5. We have the class. We don't have the exact D5. So we need to compute D5. Use it as the lower frequency L, which is 20, plus 5n, 5 into 100 upon 10, minus what is the cumulative frequency of the previous class. Previous class is what? 10 to 20. Right? So 10 to 20, the cumulative frequency is 20. So I subtract 20 and divided by 40. 40 is what? The frequency of the decile class. The frequency of the decile class is 40. Number of students 40. So we take decile class 40 as the frequency, and into 10. 10 is the difference between 20 and 30. So 30 minus 20, which is into 10. So 20 plus, solve that equation, 7.5 it comes to. So decile 5 is 27.5, right? So once you know quartiles, deciles also come on a similar line and they become simple to calculate. Now look at the next part. We are calculating decile 7, right? Decile 7, on same lines you calculate the decile 7. So you can go through this answer and you know how to compute the decile 7. So hopefully the computation of deciles are, which is quite simple. You have to just keep using the formulations and you get the deciles. And this decile will be a very useful mark to understand the various classifications that are required in the economic data analysis.